Hello everyone and welcome to the channel. I'm Emmanuel, I'm an Airbus A330 pilot, and in today's video let's have a look at the brand new beta version of the iniBuilds A320neo in Microsoft Flight Simulator. So we are currently standing on the maintenance apron in front of the Lufthansa Technik buildings at Hamburg Airport, and we're going to do a quick local flight, and we will explore some of the system depth of the airplane. We'll see how it reacts in case we turn some stuff on and off, and we'll just try to get a look at some of the system depth that this airplane has and some of the internals of its modeling and what happens when you go a little bit non-standard with it. Alright, join me in the cockpit then, and we are going to start straight up. So on today's flight, we are going to have a GPU in position. We are also going to have chocks, no jetway, no catering, no luggage, no pushback. So with that we're pretty much done. What would be nice would be a little, well, some sort of stairs or something the likes, but looks like we don't have any of that, so I'm good with that as well. Alright then, so let's go for it and go ahead and start powering up our A320. So, we're going to start. The battery voltage is sufficient, so let's start. Engine masters off, norm off, down, wipers off, and voltage looking good. External power light should be illuminated at this point, even without the batteries. Let's turn them on, see what happens. Okay, looks like... Oh, there we go. Okay. My mistake then. Alright, now it is. And here we go. Okay. Cool, so that is power established. Quick APU fire test. Look at that. When I'm running the APU fire test here, the agent doesn't illuminate quite yet. Let's give it a little while and see what's going to happen then. If you do it too early, you can certainly confuse the airplane. Right, let's try that again. APU fire test. The discharge light should be coming on. Maybe we really need to give it a little bit more time until the flight warning computer has finished initializing. I haven't seen that message yet on the A330 when powering it up. The flight warning computer fault normally doesn't show up on the 330. Maybe it's different on the 320 though. Okay, so we'll just give that a little bit more time, but interesting to see that we do have a fault like this, because it does suggest that there's a little bit more system depth in there. Okay, here we go. Discharge and script. Perfect. So APU fire test is good. Let's go ahead and turn on the APU. Master switch, wait a little while, starter. And the APU shouldn't start until the flap open light comes on, so we'll just give that a quick look, see how it's going to turn out. But looks like it's doing it correctly, so let's just go ahead and turn on the IRS so that we have that available. On bad light, fault light, here we go. The real one after you turn on the IRS is usually going to give you a nav GPS fault message for both GPSs for a short while. Just comes up and then goes out again. Again, that's A330 though. Even though the Neo does it as well, so I would kind of expect the 320 Neo to do it as well, but must not necessarily be 100% correct there. Okay, cool. APU is starting up. Then what we are quickly going to do is to go to the MCDU menu, version info, just for you to know which one I'm using to record this. And then we'll go ATC.com, username, and for that I'll enter my SimBrief ID, 3393. Right, the rest of the ATC menu, just so that you can see, we've got weather request down there, but that's it for now, the rest is grayed out. Okay, cool, so then we can go ahead. Cockpit lights, well, we had a look at those already in the previous version, so I'm simply going to turn them off. We absolutely don't need them now, and personally I try to avoid turning them on when they're not needed, because it just avoids the panel getting hot. And even though there's no... Oh, that's a nice sound of the air conditioning coming on. what I was about to say, even though there's no high voltage in the cockpit, the MD-11, for example, got some very high voltage in the cockpit that could lead to fires. And it was known with MD-11 operators that they got smoke in the cockpit every now and then. Airbus, 28 volt, that's it. So, hardly a chance of anything catch fire. Sometimes you had smoke from the old CRT screens. With the new LCDs, doesn't happen anymore. Alright then, let's go ahead, do the recall, 3 seconds, like that, showing normal, very good. And with that we can basically go ahead and accept our aircraft. So oxygen pressure is a little bit low, hydraulic is looking good, and engine oil quantity, we're just gonna go up here, turn on the FADEC. Engine oil quantity is looking good down here as well. Alright, very cool, then we can turn the FADEC back off, and that's it. Now talking about system depth, circuit breakers up here don't seem to be simulated at all, none of them. Okay, cool. So, with that done, let's go ahead and do the normal pre-flight procedures. So, oxygen crew supply, let's just turn that off, see what happens. Turns amber. Now the A330 would also cross it out, but not sure if the A320 would do that. So, crew supply on, ground control, CVR test. And in the A320 CEO, when the parking brake was released, that's not supposed to work. Let's see if it's the same in the Neo. Okay, in the Neo it does sound, again, might be a feature, or might not. Can't say for sure. So, none of the emergency alert buttons here work. The GPWS buttons do though, and the flight control computers work as well, so we can play with that later on in flight as well. Alright, it's just the pilots and a couple of engineers today, so pack flow is certainly going to be low. Then, engine fire test. Works, and look at that, you can actually click them if you want to. Now, I'm tempted to give that a try later in flight, but let's talk about that when the time has come. Alright, cool. Then, let's see what our weather is. Let's go ahead and import the Simbrief flight plan over here, Lufthansa 9941. And that is looking good. So, latest Hamburg weather, QNH 1023. Takes a little while to tune, but here we are. Date and time are correct down there. Very good. Then, we want to transmit on COM1, and we want to listen on that as well. And we want to listen on COM2, perfect. Intercom, turn that up as well. PA button. Hey, that even works correctly. It only works when you press it down. When you let go of it, it immediately goes off again. That's very cool. Okay, so that's that part. Squawk 2000, and we'll put it on above. And that's it. Very cool. Okay then. That's that part, so let's go ahead with our FMS preparation now. So, start on the data page with the aircraft status. It's an A320-200 LEAP engines. Database is active at the point of this recording, and it actually stored the waypoints that I created last time. That's very cool. However, pilot waypoints we would usually delete at this point. Align IRS, we're about to do that anyway. Okay, init ref, let's see if we request our flight init, whether that is going to work or not. Let's clear that align IRS, error downloading data. Okay, so be it for now. In any case, then we are just going to program the route manually. It's Hamburg to Hamburg, no plan route, alternate, Lübeck, flight number Lufthansa 9941. Okay, cost index 20, initially going to climb to 20,000 feet, and then later 35,000. IRS in it, looks good. Wind, let's see. Okay, looks like I can't do wind request here, so something's probably wrong with the username, but we'll figure it out later. Okay, departure runway 33. Now, Yes, I'm aware of the error. Let's get to work then. Operational flight plan, Econ 1 Golf departure. That's it. Econ 1 Golf. Here we go, and then let's continue entering the route. It's going to be direct to Bokmu. So, Econ, Bokmu, Lima, Alpha, Golf. Oh, that's interesting. Temporary flight plan system. Yeah, I know. Do I really need to have to insert all that stuff here? I really need to do that one by one? That's not how the real one would work. Okay, next target. What's interesting as well, in the real Airbus, when you've got something in Scratchpad and then a message comes up, and you clear the message, what you had previously in the Scratchpad should be retained. Looks like on this one it's just removing that stuff altogether. That's not what should happen, but we've just seen it. But, alright. So, please wait. That's taking quite long. I tried that on the real one. It went quite a bit faster. Okay, towards Throttle. Here we go. Temporary insert. And for the arrival, for now we'll plan ILS 05. Delta Hotel 257. And... hello, I want to go back to the previous page, please. Okay, looks like we need to do that again. ILS 05 is correct. And it's going to be the Rarup 5 Alpha to the Delta Hotel 257. The real one, by the way, would select the direct or the via automatically when the star is inserted. Alright, so flight plan is in, but it shows the destination incorrect. Why is that? That's interesting. Should say Hamburg 05 down there. Okay then, copy active, and we're gonna go to... well, tried that on the previous one. We need to create a new waypoint here. So let's go to stored waypoints, items, Hamburg X4. Like that, and then we'll take Hamburg 33/330/25 miles. DVD waypoint is in. Okay, and in the secondary, Hamburg X4 for the engine out. Here we go. And then we can enter a holding down there as well. Insert that, fine. And then new destination Hamburg for quick return for an ILS approach runway 05. Insert. Very good, so that is our secondary flight plan prepared. Now we can go over to the primary, fix info, and say Hamburg runway 33. And I want to draw an extended center line, so we'll take a radial of 330 in here. And that's our extended center line. And if we have a look at that on the plan, you can see that's just about perfect. And if we take the secondary, then we should get our emergency waypoint. Here we go. Hamburg X4 is just over there. Alright, perfect. So that's pretty much what we wanted to do. Okay then, let's go on. Over to the weights, we are simply going to import them automatically. And for the fuel, 5.4, but let's just take the fuel planning tab, see what's gonna happen. Let's just have it run that automatically. Interesting, it should obviously give us a block fuel value now. Oh, let's click confirm. Alright, well that's interesting. 5.4 is correct for sure. That's what we've got in there. Should be 5.3 by the way. So 5.3. So, trip fuel is rather high. That's surely not going to be 21 tons. But let's try something. So if we go lateral revision, should have a step out feature anywhere there, but I do seem to remember that we find it here as well. Perfect. So 350/Bokmu. Not allowed. If we take only 350, Format error. That's interesting. Well, let's play with it. So let's say we want to do stat climate acon. So 1350 slash acon. Is it going to do that? No. Well, let's try in-flight again. So if we put just the altitude, should allow us to do that as well. Just want to try something lower to see whether that had any relevance. Like, no. Okay. Well, we'll play with that later on again. In the meantime, let's see about our reserves down there. So, here we go. Alternate fuel 700 kilograms, final reserve 800 kilograms. So we've got 0.7 and 0.8. Final is okay, even though it should be 30 minutes, not 10. Okay, well, so be it. Taxi fuel, we'll just let it be. Alright then, let's do some takeoff data stuff. So, takeoff, synchronize, and calculate. Air conditioning on, force tow guard no, NEIs off, that looks good. Alright, cool. Center FMGS. Data sent, data confirmed, even though it didn't put the flaps in. Let's try that. It's gonna be flaps 1 and a trim of 1.5 up. Like so. Alright, so we are just gonna take that. Next phase, I want to try an initial speed restriction of, let's say, 200. Let's pre-select that, and let's see how that is going to work. Alright. Last thing that I do in pre-flight now is go to stored routes here, but not simulated at the moment, so we'll have to live with that. We'll try the equi-time point and stuff like that in flight, so for now we are good and done with that stuff. Okay then, ground, let's close the doors. Park and brake is set, so trucks can go, and the APU is running anyway. Let's have a quick look into the ELAC page, see how that works. Right now I've got the APU generator feeding AC bus 1, external power AC bus 2. That's interesting. Now, that is different from the logic that I'm aware for the Airbus. The logic that I'm aware, now that's A330, is when any external power is on, should override the APU generator. So APU generator shouldn't power anything as long as external is on. But let's go ahead and have a look. We've got a load on the APU generator of 26%. Let's see what happens when we disconnect external power. 58%. Okay, cool. Now I just want to play with it. Let's put the external back on and APU off. Now this is non-standard configuration, but the external power took over everything. Okay, so that's quite alright. So APU generator on, external power off, and then we can remove the ground power unit over here as well. Okay, cool. So last thing for us to do, initial climb gonna be 5,000. We'll take constraints up here, and the 2 VORs are gonna come on. So this is like normal configuration I would be using in flight. Alright, cool. So that's pretty much our preparations finished down here. So let's go ahead and read the cockpit preparation checklist. Gear pins and covers removed. Fuel quantity. That's 5,360 kilograms balanced. A little bit less on the left side because that's where the APU is fed, as you can see on the display down there. Seatbelts on, ADRs. We go to the data position monitor. That's nav and barrel ref QNH 1023. Cockpit preparation checklist complete. Little note there on the nav down here. You can see there's a tiny difference in the 3 IRS positions, and that's completely acceptable. So that is completely normal, that right after alignment you can have a slight difference of like 0.1 nautical mile there. Alright, so that looks good. Quick thing, by the way, that we can do on here as well: pause monitors, select nav aids, I can deselect something. And I just want to deselect the Ulster DME that we've auto-tuned on the radios. So let's deselect that. Interesting, that doesn't seem to work. Alpha Lima Fox, deselect. Okay, that's not working. Because that should have removed Alpha Lima Fox over here, and it should have selected something else. Okay, deselecting the GPS, however, gives us GPS primary lost. And on here, GPS primary is missing as well. Okay, so there's some logic behind that, not everything. Okay, select GPS, GPS primary is on. Perfect. Okay, cool. So a little bit of playing over there, but that is totally fine. Okay, cool. So I'd say we are about ready for our engine start. The APU is already feeding the plane, so let's carry out the before start procedure. And that is looking good. Slides again should be armed, but not sure we can convince them to do it. So let's see. I just pressed the call buttons. Let's see if that makes any difference, but it probably doesn't. So we are fine with what we have. Whole thing, clean speed 180, so let's do pre-select 180, so that we are going to continue to climb at the clean speed. Alright. So, before start checklist. Park and brake. Set, take a speeds and thrust. Got a 145, 145, 147, and flex 58. Windows, closed, beacon, on, before start checklist complete. Okay, it takes a little while for the FADEC to power up, as you could see by the axis on the indications. But here it is, so engine 2 starts. It's going rather quickly. On the real Airbus there is a slight delay between the N2 rising and putting on the engine master. We do have pressure down there. Igniter A is in use, as we can see. Okay, that igniter closed rather early in the process down there. It's closed at 35% N2, just after EGT light up. In my opinion, seems a little early. Then again, I haven't flown an actual Neo, so this is a little bit of general aircraft knowledge there as well. Might be different on the actual plane, so don't take everything granted here, but rather unlikely to me that the starter cuts out that early. Okay, so avail light should come any moment. Here we go, engine 1 start. So let's see that again. N2 rises very early when the igniter opens. EGT constant, 3 degrees outside, so 20 is probably the lowest value it can display. So let's have a look at the N2 and the igniter. Igniter went off at 32% just when the fuel flow started. That is definitely too early. Like, just when the fuel flow starts, the engine is not yet at an RPM where it can sustain itself. So I don't know where exactly the self-sustaining RPM for the LEAP engine is, but for the CFM56, for example, it's roughly at some 45 or 50%. So anyway. Okay. So, engine is available. So, 1.5 units up, like so. And then we can do the after start checklist. Anti-ice, off. Ecam status checked. Pitch trim. That's 25% set. Rudder trim, neutral. After start checklist complete. Okay, flight control check. Full up. Full down. Neutral. Full left. Full right. Neutral. And the rudder. Full left. Full right. Neutral. Now there's something I want to try. Note the fuel flows down here. 300 kilograms per hour per engine. I'm gonna turn off pack number 2. Let's see what happens now. Normally the fuel flow on that side should go down a little bit to like 300 or maybe 280 kilograms. But looks like it's staying constant down here. In my opinion, shouldn't happen. Just want to try something. What happens when I turn the thrust bleed valve to shut? Let's see if that makes a difference. No. Okay. All the rest of that stuff we're gonna play with in the air, so we'll just leave that stuff as it is for now. Alright, cool. So, clear left side, clear right side. Lights coming on, brake coming off. Plane should definitely taxi on idle thrust. And you can see it actually does. Okay, brake check. Let's see what's gonna happen. Applying brakes now. Pressure 0. Perfect. So with that we can say that the primary braking system has taken over, because the brake pressure indicator actually shows you the backup system. Okay then, we'll taxi over the maintenance apron, over to the main side, and then we'll take things over from there. So this is all with idle thrust for now. By the way, I want to try something. We've got the cabin check up there. What happens if I ding them? Okay, it goes to ready immediately, so that's the logic we've got in here. Obviously, since we are doing a ferry flight or a maintenance flight today, you know, you wouldn't get that kind of stuff in, you wouldn't have a cabin crew, so when you tidy up the cabin, you just press the ready button and that's it. So that stuff out of the way. Auto brakes on. Down here everything is checked. Weather radar coming on. And the takeoff config is okay. So don't have any changes to takeoff briefing. Everything is pretty much exactly the way we briefed it earlier. In case you're wondering, the scenery we're using up here is Hamburg from WinWings, available through Marketplace or from Aerosoft, who initially released it as a publisher, you name it. Quick look on the outside as well, what we can see. The wings seem to be rather stiff during taxi. Well, I can probably see a little movement there. Probably a little. Well, let's see from different perspective. Yeah, not sure if they're moving or not. If they are, then it's not really visible. Which in my opinion is realistic, by the way. Fair enough, on the taxi they can sometimes bounce a little bit, but apart from that, wing flaps in an Airbus, yeah, you can see a little bit in the real world. However, that little bit is so little that when you have to simulate it on a computer, you basically wouldn't see much. Tried that myself when I was a passenger on an A320, and we flew through a little turbulence. You could actually see the wingtips moving, so I just got my phone out and tried to record, because I wanted to show a developer that, yeah, you do see that stuff moving in the real plane, and then it turned out like, nope, on the recording you can't even see it. Okay, anyway, let's do the taxi checklist. Flight controls, checked. Flap settings, config 1+F. Radar and predictive wind shear, on and auto. Engine start cell, norm, and ECAM memo, takeoff, no blue. Taxi checklist complete. Okay, cleared for takeoff, runway 33. I wonder if that light is meant to be there right on the taxi line. Probably not. Well, let's go around it anyway. I want to see how sharp of a turn we can actually take with this. Let's really bring that speed down to a couple knots. Right, 1 knot. Seems good to me. Now, let's go right across the center line with the nose wheel. And full input to the left. Look good. I like it. You can see how the nose wheel is actually behind us. Alright, not the best of all my lineups, but it shall suffice. Okay, packs are going to stay on. Let's do the lineup checklist. And then we'll be cleared for takeoff straight away. Takeoff runway 33 via Sierra 9, I believe. Something like that. Well, pretty much via Golf. TCAS. That's a good point. See, that's why we're doing these checklists. Tara, packs 1 and 2 on. Lineup checklist complete. Alright, are you ready to go? Then let's give it a try. Take off. Manflex 58, SRS, auto thrust blue. Back to the center line. Thrust set. .100 knots. I just love the power. V1 rotates. The nose is jumping up a little, like, see how far up it went, even though my stick was in the neutral position already? So, positive climb, gear up. The gear lever, by the way, should be pulled out and then moved up. Okay, thrust climb, climb. Let's hand fly it for a bit. Flap 0. Speed check, flap 0. And due to the pre-selected speed, the speed window opened on 180 knots, just as it should. So let's see how well the flight director actually works. Gonna pull the plane all the way into it. In the meantime, we do the after takeoff flow. Okay, so let's take a close look at the PFD. And I'm going to try and follow the flight director as accurately as possible over here. Let's see how good that is. $1,000 to go. Okay, let's manage the speed, bring it up to the speed restriction of 210 over here. Okay, no input on the elevator. It's accelerating, and we've got alt capture. Just want to see how the plane behaves. I will accept that we're slightly climbing right now, but look at that, it actually leveled off quite fine. Or accelerated quite fine, that's the word. Alright, cool, then let's go into the turn and start accelerating again. So we just got an ECAM caution there. Ice detected. Okay, well, we're out of the clouds again already, so let's continue the climb. We'll initially make it 7-0. Let's also put the autopilot on now, AP1. Set standard. Standard cross-check, passing flight level 49. Now. Checked. Okay, so the next exercise we're going to do is we'll have the plane go in alt star, like that. Now we'll select the new altitude, and look at that, it's going to vertical speed mode, just like it should. Okay then, let's continue the climb to a higher altitude. We'll make it level 200 for now. Thrust climb, alt flight level 200 blue. Okay, so climbing nicely. Let's have a look at some of the systems right down there. So cabin is climbing at about 400 feet a minute, that's fine. Cabin altitude is showing in tenths of feet there. I'm not sure if it should be tenths or 20th, but either way, looks about okay. We're about to pass 10,000 feet, differential pressure of 4 psi. That looks correct as well. And passing 10,000. So landing lights going off, seatbelts, auto. Gonna keep these selections up here, but just for you to know, if you go to airports, it's actually going to show you all airports you have in your simulator. So that is not necessarily realistic. There should be a filter in there. Okay then, RadNav page, nothing in there. Secondary flight plan, let's copy the active on top. Also we can remove the stuff from the fix info page here. So optimum 395, max 398, cruise 200, that is fine. So we wanted to try the step altitude feature one more time here, so let's just give that another try. Let's say we want flight level 300 at econ. Like that. Not allowed. Okay. Well, looks like the step alts aren't quite working yet. What happens if we just enter an altitude? That gives format error. Now, if you just enter the altitude without a slash, it should calculate the optimum step climb for you. So that's what it should do. Okay, well then we're going to try something else. Climbing flight level 200, if we just select a higher altitude. Like for example now, let's say 300. I note that I did not press the button. It says new cruise out flight level 300. Should only do that when I actually press it in like that. So, not 100% accurate yet. Anyway, we've got flight level 300 blue. New cruise out 300, new cruise out 270, that should have gone. That should have vanished earlier anyway. But okay, that's fine for me. So let's have a look at a couple of the FMS pages that we've got in here. Or before we do that, let's actually have a look at the different ecam pages. So we are just gonna go and scroll through all of them, just so that we got an idea of what we actually got. Pack flow is low, as you can see, and I just want to try what happens if we go to norm. Yeah, look at that, you can see the pack valves actually moving there. That's quite cool. Also we can see different temperatures associated with it. Let's just try high, see what's gonna happen then. And what we can also try, go back to pack flow norm, and now let's just kill a pack. Let's go pack 2 off, see what's gonna happen. We should have the pack valve in transit now, and that should have closed. That should have gone amber and closed, with the pack selected off. However, as you can see, the remaining pack automatically went into high flow, while the switch is still in the norm position. So that's like partially correct behavior that we're seeing. Only that one should have closed. Apart from that, it's looking okay. Let's turn the pack back on. And here we go. The system is going back to normal. Okay then, let's go on. Pressurization page looks fine. Then let's see about the ELEC page, looking good as well. I just want to have a little bit of fun, see what happens if I kill a generator. So let's just zoom out a bit so that we can actually see something on the display. Well, looks like we can't really. Okay, so Gen 2 off. And Gen 1 is taken over. The ECAM message displays ELEC Gen 2 off. Okay, and down here we can confirm that that's actually the case. So Gen 2 off, then on. That's ELEC Gen 2 on. Problem solved, ECAM message gone. That's exactly how it would work. Okay, a little bit later we're going to try something different, but I'm in the mood of playing at the moment. Alright, so hydraulics are looking alright. In the A330, the hydraulic quantity down here would actually decrease a little bit in flight because there's quantity in the system. I'm not sure if the same happens in the A320. In the 30 it would. Also the pressures would never be static, but they would vary a little bit. Wondering about the PTU indication over here. Let's give it a try. Let's go to the yellow hydraulic system, for example. So, yellow engine 2 pump off. Pressure decreased very quickly, but again we're getting correct ECAM message there. Hydraulic, yellow engine 2 pump low pressure, yellow system low pressure. That looks alright. We'll turn that back on now. And that's it. One thing we can give a try, again not 100% sure if it works in the 320 like that, but in the 30 it does. So engine 2 pump off, ELEC pump on. Let's see how much of a pressure we're getting now. We should get 2,500 in the A330. But again, that's an A320 here, so this is actually going all the way 3,000. Alright, fair enough. Let's revert that switching, and here we go. Okay, so fuel page, fuel temperatures, -1 at the moment. Oh, engines are going to idle, why is that? Reach cruising altitude and target speed is lower. Okay, fine. For a moment I was worried that I might have killed an engine, but doesn't look like it. Doesn't look like it. Okay, APU obviously shut down. Temperatures down here. Looks like it's really inserting just the hot air to warm it up. Okay, door page. Well, why do we have a cabin vertical speed of 600 feet a minute? We see that over here. Cabin is still climbing, 8 psi. Let's see, pressure page. Yeah, differential pressure might be a little high, so that step climb might have confused the pressurization system a little, but that's alright. Okay, wheel page looking good. The brakes, yeah, we barely used them, so 30 degrees sounds alright. And the flight control page looks all good to me as well. Okay, so let's do a little test there, and we are going to go ahead and switch off the autopilot. Like so. And now I just want to see how the airplane is going to behave. So, flight director is going off, birdie is coming on. Alright, so what we're going to do now is at first some normal maneuvering, and in the air it really should behave about the same as it should on the ground. So I'm just doing a little bit of left stick, right stick. No major changes here. Now let's do a little bit up and down. But keep in mind, since you don't command an actual control surface movement, but since you command the G-loading in the airplane, basically the same side stick movement at high altitudes should result in the airplane behaving about the same as it would in lower altitudes. And that actually looks okay to me. So let's start our right-hand turn to get back on track, and this time what I'm going to do is I'll fly the airplane all the way to a bank angle greater than 30. 35 should, or let's make it 45. Release the stick, and is rolling back. Nice. Now let's do full side stick to the right, At the same time, try and maintain altitude. So full stick to the right. Oh, lovely. That should absolutely not have happened. You cannot overstress an Airbus in normal law. You can't. Alright everyone, here we are again. So that was certainly a failure of the fly-by-wire system test. It is worth mentioning that with the present beta that I'm using of Microsoft Flight Simulator to record this, the airplane is, or the simulator itself is constantly resetting the assistance settings to easy, so I have to turn them back to true to life, but then I sometimes forget to turn off the crash detection again. Anyway, this was a very good example why Microsoft Flight Simulator's crash detection is, well, shite. Okay, so let's return to the fun of things though. So a couple things here. I had to continue recording the video like 2 days later, so we've got a different weather scenario right now. It's now runway 23 in Hamburg and it's a little bit rainy and everything, but we'll get to that when we start our approach preparation. In any case, now the simulator should be configured so that we can no longer overstress the aircraft and end our flight. So let's turn the autopilot off once more and see what we can turn this one into. So, flight director's off, bird on. And let's just go ahead and see what we can do now. So we were about to conduct our steep turns while trying to maintain altitude. Well, let's do that again. This time, no crash should be detected. Needless to say, by the way, that with the Airbus in normal law, you should not be able to overstress the airplane. Regardless whatever input you do on side stick, you shouldn't be able to overstress it. Okay, well, let's return. So that was kinda, well, it did what it was supposed to do. And it went into toga lock, so thrust lever is in toga, auto thrust disconnect. Set auto thrust disconnect, please. Hello there. That's not how the toga lock is supposed to work. Okay, here we go. Interesting, showing auto thrust, but no mode. That's not so... Oh, that's interesting. I think we broke the auto thrust. Let's put it in toga. Then back. Yeah, looks like we broke the auto thrust. If I press the disconnect button again, maybe that's gonna do a difference. Well, interesting. It should go into speed mode now. But maybe if we give it some flight director again and a vertical mode, maybe that helps. Let's try that. Yeah, here we go. Okay, that's better. Alright, so just give me VS0, speed is back on, flight director back off, here we go. That's what we wanted. Alright, well, that was interesting. That was certainly not the kind of behavior that an A320 is supposed to show. So, that was definitely a bug there. Okay, well, so let's go ahead with our next exercise. On this one, we are actually going to bring it all the way into the overspeed protection, and thereafter we're going to go all the way into the underspeed protection. So we're going to test the two protections. We'll just maintain the flight level 280 in this for this one. Down we go. And interestingly enough, we're showing 2.7 miles left of track, even though we are at least showing to the right of our route, and the route itself is just, well, not the way how an Airbus would have drawn it. In any case, let's just try to fix that, make a direct BOCMU. Direct BOCMU, insert. Oh, that's interesting. That is interesting. Well, 173, that's about right, and we're flying manually, so let's not care. Okay, cool, then auto thrust coming off. And we are going all the way into maximum climb thrust. What we'll do is we'll simply let it accelerate until we're going into the overspeed protection. Might take a little while, so might as well just continue our descent to flight level 200 already. So down we go. So let's see what is about to happen. What should happen is that it lets you go to the green sign over there, and thereafter the nose should start coming up. So let's see what it is actually going to do. This is just exploring the flight dynamics of the iniBuilds A320 and seeing how the control logic of an Airbus fly-by-wire is implemented in this one. So let's see. Should get the overspeed warning from the green sign on. Nose is coming up. Very good. Okay, but silence please. Nice, the emergency cancel button works. Alright, and now the nose should go kind of back down so that it maintains the speed 8 knots above the maximum at the green equal sign. That's where it should stabilize. But it looks like this one is just keeping the nose pointed at where it is. Or maybe after we're out of the overspeed area. Let's try full stick forward. This is full stick forward now. Let's see what that's gonna give us. Stick is fully forward. Nose should come up. Well, looks like that's not working. Should keep us at 20 knots in the overspeed now. And it doesn't. Looks like we can manually override the protection. Now I'm letting go of the stick. Nose is coming back up, but we should not be able to manually override it more than 20 knots into the overspeed. 20 knots is the limit the airplane is going to let you do. Okay. It's recovering though. Nice tram tractor getting back out of it. Let's start a slight left turn here in order not to deviate from our route too much. I didn't want to do the turn on this exercise because we were overstressing the airplane anyway. But we just saw another nice feature of the fly-by-wire. So let's we need to see the side stick and the PFD at the same time. So when you're in the overspeed, the roll rate of the airplane is going to be reduced. So let's bring it back into the overspeed. Look at that, it's trying to roll the airplane back to wings level. But now, when I'm doing an input, look at the side stick input versus the roll rate I'm getting of it. This is full side stick now. And you can see the roll rate is significantly reduced. Now let's get back out of the overspeed. And I'll just show you. Full side stick input, this is the roll rate we get. And now watch it as it goes through a certain threshold on the speed. And you will see the roll rate increase with the side stick at the same deflection. Now let's go back to the left. See that? Now we're rolling a lot faster again. So that is correctly modeled. Right, now we'll try the same on the other side. Let's go thrust idle. And now we'll try the low speed protections. I'm just going to gain a little altitude here. Trading speed for altitude. At the same time, let's just go 30 degrees nose up. And this is side stick still, full aft position. Here you can see it. And it's limiting us at 30, just as it should. Alright, cool. So, I'll just let it go straight into the underspeed protection. Oh, that should be impossible. Nope, that is not good. What's the airplane doing? Did it really stall? In normal law, the Airbus? Did it like really stall? Okay, let's gain a little speed, and now this is full aft side stick right now. Hello, get my thrust off, please. Can't disconnect the toga lock, it seems. It's certainly got some issues with that. Okay, here we go. Okay, well, that was interesting. The fact that you can't just disconnect the toga lock the way you do in real life is a little, caused a little overspeed, let's put it that way. And even the speed brakes couldn't prevent that. Obviously. Okay, well, so several things that have just gone wrong with this one. Speed brake coming up, let's go up again. We need a bit more altitude if we want to repeat that test. So, several things that just went out of the ordinary here. Really, several. So first of all, in normal law, you should not and never be able to get the Airbus into stall. Can we just get rid of that auto thrust off, please? No. Well, clear it. So yeah, that should have been impossible. It should have taken the nose down far before we actually entered the stall. And by taking the nose down, the G-loading would have reduced, and that would have avoided the stall. So the stall warning in normal law, impossible. Shouldn't happen. In alternate law or in a direct law, obviously it can, but not in normal law. And we definitely were still in normal law. We're going to do a couple checks in terms of alternate law later on, but that's gonna be for a later point in the flight. So, for now, what's going to be interesting here, let's level off in 200. I'll pull the thrust off. And now we'll try this approach to stall a little bit more gently to give the system a chance. Like, right now, it was fairly extreme. Now, to be fair, during the type rating, we did try this very maneuver, and the A330 handled it perfectly. But let's try a little bit more gently to give the system at least a chance. So, we are going to let the speed decrease, and there are several things that's supposed to happen. First of all, we're going to enter the alpha protection, later on the alpha max. But the first one is VLS. So VLS we can enter without problem. Alpha protection we can enter while keeping the stick back. And alpha max we cannot override the airplane anymore. It is going to take the nose down no matter what. So we are going to give these a try. You can easily tell what they are looking at the PFD. We've got VLS, lowest selectable. This is only for auto thrust. Auto thrust is not going to fly you into that, if it can avoid it, aka if it has sufficient thrust available. But that we can easily fly into. Below that we got the alpha protection, that one. In this area, the airplane is automatically going to take the nose down, but you can override it with a side stick. And then you've got alpha max, which is the red area that you can just see come into view down there. And that one we can no longer override it, the nose is gonna come down. So, let me pitch up a little bit myself. Now the side stick is in neutral, it's holding the pitch, perfect, that's what it's supposed to do. No side stick input, as you can see. Once we enter alpha prot, the nose should start coming down. Oh, nice wind shift. So, no side stick input at all. Let's see what the airplane is going to do. So, here's alpha prot. No. Nope. There should absolutely not be a stall warning. That is incorrect behavior. It should simply have lowered the nose. So that was absolutely incorrect. Okay. This is interesting as well. It's showing auto thrust active, but no mode. That also should not happen. Okay, so the low speed protection is currently certainly not working correctly. I think we can absolutely agree on that. Low speed protection is not working. So we did an accidental stall test already. And then we could determine later on that the low speed protection just is not working. Okay, well, suppose we can live with that for now. So let's do another couple of tests. Let's just bring it back into level flight. I'm going to keep the autopilot off for now. Let's make some 65% or so. Yep, that's keeping a nice speed over here. And just bring it back in level flight. Doesn't need to be exactly level 200. Just something where we are neither climbing nor descending. Okay, so now I want to see what's going to happen when I turn off the flight computers. So let's bring up the flight control page down here, and we're going to start with the LX. So LX 1 off. There you go, flight control, LX 1 fault, and it's reverted into alternate law. That should have been the first thing, by the way. Alternate law is usually more important. Okay, so LX 1 off then on. If unsuccessful, LX 1 off. Okay, well, we turned it off intentionally, so we're going to ignore that. Clear flight control. Clear flight control. Okay, flight control. Alternate law, protection lost. Speeds, brake, do not use. Maximum speed 330 or 0.82. And rudder with care above 160 knots. Clear flight controls. Clear flight controls. Okay, that's the flight control page, but we brought that up manually, so that's ecam actions complete. Okay, so that's alternate law now. We no longer have bank angle protection or high and low pitch protection, and no longer have the other protections as well. So let's just give that a try. We're going to roll past 67 degrees to see if that's actually working. Yep, it is. Okay, and here we are again. Lost a couple feet in that, but with alternate law, you'll see if you look at the relationship between the plane banking and the side stick input, that's gotten a little bit more aggressive there. However, it technically shouldn't, at least unless the A320 is different from the A330 there. In the A330, alternate law would still give you the same response of the airplane on the side stick, but, well. Okay, now let's turn off LX 2. That should have triggered a new ecam. Let's see, status page. Oh, we've got LX 1 and 2 on there, so we should definitely have gotten a new warning. Okay, but we can live with that. Let's do a recall. LX 1 fault, LX 2 fault. Yep, so that is definitely new. That should have shown. Okay. Anyway, we're going to clear all of that. And let's go back to the flight control page. So, still alternate law. Now let's try something more. Let's go about the secondaries. Sec 1 off. Flight control, Sec 1 fault. That's intentional. And the only new thing we have now is speed brake do not use. Well, we actually had that before as well, so clear flight control. Okay, let's try Sec 2. Again, should have triggered a new caution, but you can see our systems are slowly degrading. Now we've actually lost all ailerons already. Let's see. Yeah, look at that. No more aileron control. If you want to control the bank, you need to use the rudder now. Let's use a tiny bit of right-hand rudder. You can see that gets the airplane rolling. So we're in mechanical backup right now. Elevator is still working, but very slowly. Which is interesting. Actually it's not. Okay. So we... Oh, it's auto trimming. That's not supposed to happen. Well, let's just go ahead and kill Sec 3. Okay, now it's man pitch trim only. In other words, now it's on... Well, are we trimming? No, we aren't. Come on, trim. Trim. Okay, it doesn't trim. Well, in that case... Oh, that's interesting. Well, I'm flying it far beyond what iniBuilds has probably programmed it for, so let's be fair to them here. Okay, here we go. Yeah, auto flight, auto thrust off, thrust levers move. Here you go, my friend. Okay, well, so normal law worked quite well, alternate law, kinda, and direct law, well, not so much. I mean, the plane was pretty much in trim, so when we entered direct law, the nose should not have come down. But apart from that, let's be honest over here, for a default airplane, that is pretty amazing already in what we've got here. Okay, cool, so let's just level off. Don't need to climb all the way back towards 200, as all we got left is a couple of system stuff that we want to check, so let's make it 180. Flight director's on. Give me a heading, give me a descent, autopilot. I said give me heading. Oh yeah, it's on track due to the bird, but... Interesting, I cannot enter a vertical mode anymore. Did we break it? Oh, vertical speed works. That shall do. Let's try again, 180, level change. Nah, doesn't work, okay. So it looks like we broke something. But let's be totally fair here. We did things with the plane that it was probably not made for by iniBuilds. So that's alright with me. That's alright with me. Okay. Well, let's try if we can reset it, though. Okay. And interesting, here we go. Oh, 180 as truth. That's alright. Just want to see if I can regain my vertical modes other than vertical speed somehow. I'm just thinking if I'm bringing it into a mode change, like now all-star. Let's see now, 190. Here we go. Now we can enter now we can enter open climb again. Okay, so that was just a little bit of playing around with the airplane, but we got it back. So small trick there. If you're at a certain altitude, you just enter 1. Put that in here. Normally, it should revert directly to the current altitude. Over here, it seems to take a little time. New cruise out flight level 180. But, well, we are there. That's what we wanted to achieve. So, it's okay. It's okay. Alright, let's go ahead then and play a little bit around with our systems. So, what are we going to start with? Well, engines. Nah, we could try if it is capable of an in-flight restart, but let's defer that to later, because in case it's not, then we can no longer do all of the rest of the lovely stuff over here. But, bleed system. Let's just see what happens if we kill the engine 2 bleed. Communication down here should be closing. Seems to be reacting correctly, but the system's indication are not. Let's see, open the cross bleed. Then it does open. Well, okay. Fine for me, even though down here, obviously, we shouldn't get that anymore. The intermediate pressure valve should be closed, because that's effectively what you're controlling with that switch. Okay, well, we're gonna start the APU, see what happens, because APU bleed should be disconnecting both engine bleeds. So let's just bring that up. In the meantime, we can go ahead to the pressurization controls. So, down here, you can put them into manual. And now let's just see what we can achieve. So, system is a little bit different on the 320 from the 330, since the 320 is a smaller airplane, so it has less outflow valves to control and stuff like that. But we've got the manual vertical speed control up here, so let's just see if we can make the cabin climb. Yes, we can. So we just manually open the outflow valve a little. You can see the cabin starts climbing straight away. Okay, well then we're going to put it back in auto. Let's see if it recovers. Yep, it does. Next sum is going to be manual landing elevation. Let's just put it somewhere. Like 5,200. And now the cabin should start climbing all the way up to 5,200. Obviously it's going to go very slow, so this is not an experiment we would be doing for long. But I just want to check that the system is responding, which it is. So that gives us an idea of the system depth that iniBuilds is actually going for over here. Right, APU is available. Interestingly enough, we heard an electrical click here, so that shouldn't have happened because the APU generator did not go online. You should only hear that when the generators are switching, but that hasn't happened. It's available, but it didn't go online. In any case, we're going to try just that right now. So let's go elec Gen 1 off, and the APU generator is taken over. Okay, ecam. Elec Gen 1 off. Generator 1 off, then on. Okay, elec Gen 1 off, then on. Generator's back online, ecam message vanished, perfect. Still got something in status, cancelled caution over speed, okay. Well, that's fine, we can live with that. Okay. Cool. So that stuff is working. Now let's go back to the bleed page. And in case you do an overweight landing, the checklist is going to ask you to either turn off the packs or turn on the APU bleed. If APU bleed is turned on, then the engine bleeds are going to disconnect and the APU bleed is going to start feeding the system up here. Let's give that a try. APU bleed on. Okay. The APU is actually taking over up here. The only difference is, it seems like the intermediate pressure valves down here don't seem to close. So we figured that earlier already, because now if I'm forcing it manually, if I turn the engine bleeds off, yep, bleed 1 and 2 off, clear air, then you see these should definitely have turned off down here. So we can say these indications down here are probably not working, but the system logic up here definitely is. So that's quite cool to see. Let's just quickly go to the pressurization page, see how that's developing. But looks like the airplane is able to control pressurization just normally, and air conditioning down here is working as well. Okay. So yeah, apart from the bleed valve indication down here that doesn't seem to be working right now, the rest of the system logic actually seems fine to me. Well, let's just try one more. I'm gonna turn off the entire bleed system. Let's see what's gonna happen now. It's complaining up here that it can't do anything. Let's go to the pressurization page and see how quickly the cabin starts climbing. Get the pack 1 and pack 2 off indications down here. That's exactly as expected. Cabin altitude climbing, 380 feet a minute. We get the 0 PSI indications in here, by the way. So that's correct. The only thing that's not correct down here is the indication of the intermediate pressure valves. Apart from that, seems the bleed system is actually working quite well. Okay, going to turn it back on now. And that should be it. Okay, so the bleed system is actually simulated quite fine. Little problem there with the IP valves. Apart from that, it's working quite well. The plane is reacting the way it should. We're getting like a realistic rate of climb, rate of descent from the cabin. So that looks pretty good to me. Okay then, so we are just going to keep the APU for a little, because next up, let's go ahead. Electrical system we basically checked already. Not a lot we can say about that. Fuel system. So, let's go on. Fuel. The only thing we can really check there is the trough feed valve. Apart from that, so trough bleed or trough feed on. Thing is opened up. Let's go ahead and shut down the right tank pumps. Now the left tank should be feeding the number 2 engine as well. By the way, just seeing it, let's turn those pumps back on, and we are going to turn off the left pumps now, because we got a little bit more fuel in the right side anyway, so let's just use that to balance up the fuel anyway. So, fuel, left tank pump 1 and 2 low pressure. Well, that's intentional, so Engine mode selector, ignition. Ignition. That message should vanish now, since the system is able to detect it. Even shows you ignition down there. Okay, but that seems alright to me. Well, just gonna run another minute or so. It's using 50 kilos an hour, as 50 kilos a minute, as you can see. So just gonna be about another minute, and then we're going to return to the normal conditions there. Okay. Next thing I wanna check is if we go to Rama. Let's just enter a holding down there. 1.5 minutes is correct. So that holding seems quite good to me. Insert. Let's see how it's gonna fly that. Okay. What's the fuel situation here? Why is the left tank decreasing? That was at 1140 earlier. But we keep an eye on it. Let's just start a timer down here. Running now? Yes, it is. Okay. So we come back to that fuel in a minute, and then we'll see what has happened. Okay, next up is the hydraulic system. And then we can also test the fire extinguishers. And with that, I think we covered the major systems of the A320. So first of all, clear fuel. And that's gone. Okay, so just giving it another 20 seconds here for the minute to elapse, and then we'll go back to the fuel system and see what's happened. Alright, so we're about at a minute, but looks like the fuel configuration here isn't really doing anything. You can see fuel quantity has decreased likewise in both tanks, so it looks like the fuel pumps really don't seem to do much here, and our cross-feed configuration doesn't seem to do anything, so looks like there's a rather large bug there in the engine fuel system. Okay, we can live with that. So let's just return to normal configuration here, like so. Cross-feed should show amber while in transit. Here we go, now it's closed. Well, not exactly the best, but I suppose that is fine. Okay then, so stop the chrono, reset it in case we need it again, and that's it. Right, so next up we're going to have a look at the hydraulics. So we're going to start by simply turning a little bit of stuff off and see what's going to happen. So let's do hydraulic green system, engine 1 pump off. PDU is taking over, pressurizing the system. Obviously we should see something down here. And hydraulic green engine 1 pump low pressure. Okay. Well, PTU off. Let's see what's gonna happen now. Now we lost pressure in the green system. And we get the green system low pressure warning. Okay, clear hydraulic. Let's have a look at the status page down here. Landing gear gravity extension, landing distance procedure apply, alternate yellow braking with any skid, increased fuel consumption, slats, flaps slow, Cat 3 single only, in-up systems, blah blah blah. I'm not gonna read over all of that right now. What is our airspeed doing? 200 knots. A little slow to me, but we'll just let it do that. Let's see what's gonna happen. It's probably reducing to holding speed over here. 200 just seemed so slow to me, but that might just come from the A330 as well. Alright, so let's go ahead and that status seems to look okay. Now let's make it a complex failure. So, blue system, elect pump off. Blue system is dying, and that's a little more interesting here. Okay, so first thing that I just about noticed is I have no flight controls anymore. Well, I have a little bit of an elevator, but no ailerons. Come on. Just shut up. Alright, well, we're going to restore that system pretty quickly here, because I can't cancel the oral alert, which should be doable. In any case, looking at the priority of the failures on the ECAM, autoflight should always be at the top. So, autoflight is always most important. That should be at the very top. Below that, hydraulic green and blue, system low pressure, and then the flight control alternate law. So if we have a quick look into the status page now, we can see there's a lot of systems inoperative. And on the A330 at least, we'd get quite some more indication on the status page as well. But this is going really into complex failures, so let's put it that way. I would not expect the default airplane to handle that kind of stuff correctly. Can we? Oh, we can kill the autoflight. Interesting though that we gotta do that way. It should be possible through here as well. In any case, that's a lot of failures down here. Let's just see. We press that. Well, that's interesting. Looks like we can't stroll through the in-op systems down here. Should be able to, but it doesn't let us. Okay. Well, so be it. Can't change it now. In any case, let's go ahead and restore the systems. And here we go again. Okay. So, flight controls are also working very good. Then the autopilot is flying once again. Well, oh, interesting. It opened the vertical speed on a positive. Shouldn't do that. When you just pull it out of the dashes, then it should just open on the current vertical speed, not on anything that might have been set previously. But okay. So let's quickly restore all our systems to normal operation. Well, we're going to keep the APU, I tell you. Hello? Oh, interesting. Looks like we cannot interrupt the shutdown sequence. We certainly should be able to. Okay, so there is one more system that I want to check. So let's go. Heading 140, something like that. 135 works as well. And that's an engine shutdown. So, first thing here, let's just about increase speed a little bit, because I'm not 100% sure what's going to happen once we're a single engine with this. So let's go 250 knots. Now we'll let the speed increase, and in a few moments we are going to kill an engine then. It is worth mentioning that I've never done an actual engine failure on an A320, only on the A330, and the 330 got a little bit more backup systems there, so there might be a little bit of difference in the expectations I have versus the expectations that the A320neo should actually fulfill. So that's worth mentioning before we actually start this. Okay, so I am going to make things easy. Engine number 2, fire switch, confirm, confirmed, push. That should obviously get us. Here we go. Engine 2 fail. And the engine page should be showing on the ECAM. But let's see if it's actually able to maintain speed. Looks like it is. Okay. So, engine failure in cruise. That means we are going to put thrust levers into MCT. Obviously the thrust shouldn't go to MCT now, it's still auto thrust active, as you can see by the speed mode, so it should still be able to control the speed. It just has a little bit more power available now, or at least that is how the airplane should work. Looks like this one is fixing the thrust on MCT. Ah, okay, no, it didn't. I just pushed the lever a little bit too far and it didn't show on here. Okay, well that's fine. So now we're in the right notch in MCT. Auto thrust got control over the engine once again and should be able to maintain speed perfectly proper. What's also worth noticing here is the airplane resumes a slightly banked flight condition. That is exactly what the Airbus should do. And we've got the slip indicator basically centered. Okay, so the autopilot is controlling the airplane exactly the way it should. That's very cool to see. Now I'm quickly going to make it a left-hand turn back into the direction we want to go for the landing, because afterwards, after this little exercise, we can then resume the normal approach. Quick thing worth noticing: if you rotate the heading selector through 180 degree, like I just did now, it's going to follow it into the direction that you rotated it. So I rotated left, that's why it's doing a left-hand turn all the way to the target heading, even though a right-hand turn would be quicker to the desired heading. But that's just something I found worth pointing out in this particular condition. Okay then, so let's do the ECAM actions. Engine 2 fail. Engine mode selector, ignition. Ignition. Look at that, this time it disappeared up here, so on this one it's actually coded correctly. Thrust lever 2, idle. Confirm. Thrust lever 2, confirmed. Idle. Should notice that as well, and that should vanish. If no relight after 30 seconds, engine master 2 off. So it had all the time in the world for that, so those 30 seconds are over. Engine 2 master off. Confirm. Engine 2 master confirmed. Okay, that should not have happened. It should just have continued on the same ECAM action, but now we've got the engine 2 shut down, so fuel imbalance monitor, we are going to do that. TCAS mode selector TA. TA. Okay, clear engine 2. Now it should show us all the consecutive stuff, but that's basically the ECAM actions complete. Alright, so let's put the engine fire switch back in. That should restore normal operation to the engine. So now let's try and restart it. For that, obviously, we'd use the QRH as applicable. Now I don't have an A320 QRH or at least not the EQRH ready straight away, but I do have the paper version, so just give me a second to find the appropriate procedure in here. So that's 1 second. Okay, engine relight in flight checklist. Okay, engine master, engine number 2 off. Off. Thrust lever engine 2 idle. Idle. And engine mode selector ignition. Ignition. Cross bleed open. So that's aircon. Cross bleed open. When we do that, let's have a quick look at the bleed page. You can see it's now engine number 1. That's cross feeding over here. However, we should have the number 2 over here in amber, because the engine bleed is not available and the engine is shut down. So that should be amber. Apart from that, the indications over here seem correct to me. Okay, wing anti-ice for starter assisted flights off. And it is off. Okay, engine master affected engine on. So that's going to be engine number 2 on. Obviously, we should have automatically gotten the engine page. Engine 2 fail, that should not be triggering right now, so let's just clear that out. And let's see how the engine start is going to progress. In the meantime, I'm going to exit the hold over here, proceed direct to Rarup. Then we should be at our top of descent literally any moment, so... Okay, the engine is starting up. You can already see it's giving us lever MCT over there. Then let's start the descent to flight level 100. First idle descent, alt flight level 110 blue. And look at that, it's actually reducing engine thrust slow enough that it's still getting sufficient bleed air for the starter assist for the remaining engine over there. Now it's available. Alright, so we're basically back in normal operation now. Let's just bring up that thrust lever again. Well, this one's going to climb, and this one is going to climb as well. Okay. Cool, so that's that. Alright, then let's just restore normal system configuration, like that. Already put the belts on, even though we don't have any personnel on board anyway. And we should have been in pack flow low. Okay, cool. So that, we are pretty much done with our preparation, so let's go ahead, grab the latest weather, and then we are almost there. So, Hamburg weather, 270 at 18, gust 30, light drizzle, overcast 1700, 1008. Temporarily, 270 25, gust 40. Sounds interesting. So let's go 1008, we can pre-select that. Right, you have control, and in the meantime I am going to program our arrival. So ILS 23 is in there, that's certainly the one we're going to fly as well. And let's take Ulster. Yeah, that should have been in there, Alpha Lima Fox. 115.80. Can we do that manually? No. Okay, so something is bugged on the navrat page there, but I don't really care, to be honest. So, 1008. Then we got temperature here of 12 degrees and 27018. 270/18. Alright, cool. Then the radio minimums, or the barrel minimums much rather, 290 as far as I remember for that approach. Might be incorrect, to be honest. But unfortunately we don't have charts on here, so we cannot look it up. Alright, landing config. Well, with that weather, we're going to take config full, even though it's going to be really slow, but we'll take it anyway. And in case I missed approach, 2800 is going to be the engine out, acceleration, altitude. Fuel prediction looks good, 34 minutes extra, secondary flight plan, we'll just make a copy of the active. Alright, auto brakes low, and that's pretty much it. Alright, cool. So, I'm going to skip over the approach briefing. Don't really need that anymore. Can manage the speed. By the way, it was interesting. Our selected speed was a lot lower. Not supposed to be like that. Okay, cool. Then we just need to lose our altitude and then we can go in. So let's go direct Delta Hotel 615. That one. Insert. And then we can continue our descent. All the way to 3000. Set QNH 1008. Cross check passing 10,900 now. Checked. By the way, why is it doing a turn at just like 15 degrees of bank angle? This should be going to 30 degrees and then go straight over there to Delta Hotel 615. Let's try that one more time. See what's gonna happen this time. Nothing really. Okay, passing 10,000. It is reducing the speed rather late, and it's going to 220 knots rather than 250, which I don't really know why it would do that, but in that case, we're just going to go open descent, speed target 250, and then see what we are about to get. Okay, cool. So, passing 10,000. Lights are on, seatbelts are on, constraints, LS. We've got GPS primary with a high accuracy. That's fine. And the start selector is in norm. Alright, so that's basically that stuff. Then let's go ahead and run the approach checklist real quick. Barrel ref, QNH 1008, seatbelts on, minimum, barrel 290, auto brake, low, engine start cell, norm, approach checklist complete. Alright, slowly approaching the glide slope already. We might just as well vector ourselves in, heading 340 or so for the start. Should be good. Just a quick more test that I want to do. That's down here on data page. Go to equi-time point. That's basically, let's just take something different. Let's take Lübeck for example. It looks like we can't even change that. In the real world you can just change that around and therefore draw an equi-time point between basically anything you want. Which is quite useful on a long haul. We do that fairly regularly, let's put it that way. Okay, just helping myself with the heading here a bit. Might as well just go direct Delta Hotel 657. So let's do that. 657's in. Managed. Keep the speed in selected for now. Okay then, let's just go back to the data page over here. Position monitor. So over here, if we just freeze that position, then you would use that, for example, to check or recheck your coordinates. So no, if you've got it in unfreeze, then that's interesting though. The coordinates hardly changed. Like, I freeze it now on 0.8, so fly more or less a westerly heading. So that should stay almost unchanged. The east coordinate down there should vary quite a bit when we unfreeze it, like now. And it does. Okay, perfect. So that's working as it should. Alright, cool. Why are we going with 4,000? No, thanks. Let's go managed all over. Well, let's go managed on speed, selected on the descent. We'll just let it go down, and that's it. 170 knot restriction at Pisas. Let's see if the plane is able to make it. Should easily be able to do it, honestly. Alt star. So now comes the interesting stuff. How's the plane going to handle crosswind conditions on the landing? We'll do manual landing, obviously. Auto thrust will remain on, so that we can see how it's going to handle it. Also, I do expect quite some variation of the target speed on the approach due to the ground speed mini function. Okay, lock star. Approach armed, autopilot 1 and 2. So Pisas should be 3,000 feet to 170 knots. It's already reducing now. That is certainly too early. But we'll just let it do it. Let's see what's gonna happen. We're gonna get really slow due to the 30 knot headwind we have over here, but I'm fine with that. The glide slope indication, by the way, is incorrect over here. With Pisas and 3,000 over there, assuming that our position is correct, with Pisas over there, the glide slope should be deflected fully upwards right now. It should absolutely not be at 1 dot, so the scale of the glide slope is incorrect over here. But let's see about it. Let's see what's gonna happen. Also, we'll check on the speed. Even though the speed target is 170, it should maintain green dot. So let's see what auto thrust is going to do on this one. Nope, that is incorrect behavior again. It should maintain green dot. Auto thrust would never go below green dot with the flaps retracted. Well, let's just try something more. Let's try to... Yep, that should not happen as well. Auto thrust would never go below VLS. Let's see if it maintains it. It does. So speed is maintained fine, even though the buck is below VLS now. Alright, I'm happy with that. Let's go back to managed. And then we go flap 1. Speed check, flaps 1. Interestingly enough, the approach phase is not active yet. Even though we have overflown the decel point, as you can see over there. The approach phase should have activated. Let's do it ourselves. I wonder what's up with that glide slope scale though. I mean, not too hard to simulate a glide slope, is it? Glide slope star. Go around altitude 4000 set. Alright, so pretty slow as you can see, just doing 140 knots over the ground, but that was expected. Glide slope. Okay, so normal approach profile on the A320 is flaps 1 speed until 2,000 feet above the ground. Then you go flaps 2. When the flaps are extended in 2, you extend the landing gear. And when the landing gear is down, you go flaps 3. And then flaps full as applicable. So let's see what's going to happen this time. So we're approaching 2,000 feet above the ground. However, always have a look at your primary altimeter and not your radio altimeter, because there might be hills or anything on the approach. Here in Hamburg, I know there's not. For that reason we can use it, but in other places there may be. Okay, flaps 2. Speed check, flaps 2. Also note how the departure runway from our earlier departure is still there. That should have vanished by now. Okay, gear down. The landing gear is what really adds the drag over here. So once that comes down, you can really see the speed trend vectors going down, as it does right now. Okay, flaps 3. Speed check, flaps 3. And flaps full. Speed check, flaps full. So cabin check over there. Don't make it a habit that you gotta call the cabin every single time. Do that in real world, they're gonna kill you latest after the third or fourth flight with that same purser. But okay, landing checklist. Ecam memo, landing no blue. Landing checklist complete. Then I'd say autopilot coming off. Let's see what's gonna happen. Approach lights in sight. Cat 1.
1,000.
Checked. So we're stable at the gate and in landing configuration. The pitch is rather low at the moment, but that's due to the speed we're flying and due to the little weight of the airplane. So if you say like the pitch is off a little bit, then nah, not necessarily, because the standard pitch values you see on approaches are normally not the same when you're doing empty flights. So do note, as our wind is changing, the target speed up here is changing as well. That's the ground speed mini function of the Airbus. And what that does is basically it takes the wind that you entered down here on the approach page, and when the actual wind deviates from it, it basically adds a third of the additional wind onto your airspeed. That's the very easy version of ground speed mini. It is obviously a little bit more complex.
400.
Land. Okay, then let's look outside a bit for that landing.
300.
Now that's going to be challenging with the gusts, and doing that with an almost empty airplane. On the 737 at least, when the thing is almost empty, continue. When the thing is almost empty, then you really gotta struggle with the controls. It just flies quite different.
100. 50, 40, 30, 20.
Right, decrap.
10, 5.
Ooh, that was a lot of bank on the last moment. A gust hit us over there. But we can live with that. Alright, spoilers, reverse green decel. 70 knots, manual brakes. Well, and here we are back in Hamburg. So that was an interesting flight. We'll talk a little bit more about it once we reached our maintenance apron once again. Certainly after that stall we did, the airplane will need another check, so that was unintentional, by the way. But here we are. Okay, clear right side and clear left side. We'll just take it over onto the taxiway, and once we're there, we are going to run the after landing procedures. Alright, here we are, clear the runway, so let's now go ahead. Strobes auto, landing lights off, nose light on taxi, and spoiler disarmed. That's the sign for the pilot monitoring to start his flow. And there we go. By the way, in case you're wondering about the transponder down here, you don't need to, it's basically I did set the squawk, however it seemed like it squawked a bit. Alright, cool. So, after landing checklist, radar and predictive wind shear off, after landing checklist complete. Then let's just give it a little bit of thrust here. We're looking for the entry over there. And then we're almost at the maintenance apron already, so we are going to delay the feedback until the engines are actually shut down. One last thing for us to check over here. Start up the APU, and then we're going to do single engine taxi in, just to see how the airplane is going to behave. So we need to wait for 3 minutes until after we used thrust. Now that is absolutely reached already, so it's just a matter of starting up the APU, and then we're going to do single engine taxi. Might still be using both engines to get uphill though, and then once we're up on the maintenance apron we are going to go single engine and just see how that's going to work out. Alright, where's our APU at? 50%. Might just stop the airplane over here once we're up on the apron. Lovely jumbo jet, by the way, over there. Okay, we're up on the apron, so let's just bring it to a stop over here. And when the APU is available, then we're going to shut down engine number 2. Okay, hydraulic pump on. Right, let's get moving again. Alright, and engine 2 cut off. Clear left and right. So a single engine now. By the way, we don't hear the PTU, and that is correct. With the cockpit door closed, you can't hear it in the cockpit. Slightly losing speed. That should probably not happen, but let's just add a bit of thrust on engine number 1 and see what's gonna happen. Right, very easy to accelerate again. So, overall, very easy going. Obviously, we're at a very, very lightweight right now, so that does play a role, but look at how easy it is to do single engine taxi on this. Alright, cool. Then let's just leave the plane in the same position where we picked it up earlier. Something like that. Here we go. Okay, parking brake set, APU bleed on, and engine 1 shut down. Cabin crew, all doors to park. Well, we don't have cabin crew, but you get where I'm going with that. We still follow the standard procedure. Okay, elec pump going off. And here we go. Parking checklist, please. Park and brake our trucks. I'll clear all of that stuff. So, park and brake our trucks. Brake set. Engines. Off. Wing light. Off. Fuel pumps. Off. Parking checklist complete. Okay, let's get some ground equipment here. So we got a GPU and we got chocks. So external power on, APU off, and park and brake off. And we can start opening that door, which in this plane disarms the slides as well, interesting as it is. But that's it. So in this one we really went nuts on the systems, and we did a lot of stuff that I'm rather sure iniBuilds did not mean the airplane to do in first place. Now, what do I think of it then? How did the airplane respond? How did everything work out? Well, to be totally fair with you guys, I actually liked what I saw. On a lot of systems you could see that there was some fair background. On others you could see that it didn't do so much. For example, the fuel system, which even though we put it into cross-feed configuration, just kept feeding normally from the tanks, which is obviously not what it should do. Also, flight controls did show some very good signs of logic in the background. However, there were some issues with it as well, like 2 times we got a stall warning that we should never have gotten, and that it should have been impossible to get the airplane into. But one time we got an actual stall, which obviously should not have happened as well. But low speed protection, okay. The rest of it, well, okay in this terms means like, yeah, we better not talk about it, it doesn't work. But the rest of the plane actually worked quite well, especially in the high speed protections. So overall, I am rather happy with it. Now the feeling of flight, well, is a little bit hard to comment, because obviously I fly A330s and those weighed like 5 times as much as we just did on our flight. So obviously handling behavior is a little bit different between the A320 and the A330. But overall I tend to say that, yeah, was okay. For default airplane, absolutely. The rotation especially though needs some more work from iniBuilds. Maybe they did work on that already, maybe they are going to work on it in the future. We'll have to see. Overall we need to keep in mind that iniBuilds did say on their Discord that the version of the airplane that got published with the beta update was like 7 versions old now, so let's see what they changed in the meantime with the next beta update that we're going to get. But in the meantime, my overall first impression then is that we are getting quite a good A320neo over here. Obviously not study level, but a lot of things are there, a lot of things are correct, even some ECAM actions are there for pretty much most of the stuff that happened, and they work like partially correct. The actions shown work correctly, however the associated system display pages should have pulled up automatically, and that didn't happen. But apart from that, could restart an engine in flight. The autopilot flew correctly with the engine shut down. That one especially impressed me, especially with the bank angle, which is something that Airbus autopilots do, Boeing autopilots don't, so that is quite cool to see. And, well, overall, I tend to say that we got a very promising add-on over here, especially seeing that it's going to come for free to our simulators. So it is most definitely a very good alternative to what we had with the fly-by-wire Airbus. I'm not going to do a system comparison with the fly-by-wire because I would find it unfair to do, seeing that we've got a first beta over here and the fly-by-wire has been polished for the last 3 years. But we'll eventually get there after, you name it, after however long it takes to get a couple updates out for the A320 after the initial release, to give them a chance of polishing it once it's really been pushed to the general public. Alright, so that is the conclusion for today's flight. Thank you very much for watching, everyone. I do hope you enjoyed it. If you did, do let me know in the comments below and let me know your thoughts of the iniBuilds A320neo anyway. If you liked the video, be sure to leave a like on YouTube as well, as it does help with the algorithms, and if you're up for more, don't forget to subscribe to the channel. Finally, if you are really liking my videos, I would appreciate a small donation through the Buy Me a Coffee link in the video description below. Thank you very much for watching, and I see you all again on the next one.